Today's lesson is going to talk about how to write equations of parallel and perpendicular lines. And I want to start off by showing you what's going on with parallel lines. So if we were to count the slope of each line, let's say I'd start here and I go up and to the right, that is a 1/2 slope. So this line slope is 1/2. For this one, again, I can start here and go to here, and I still go up 1/2. So that slope is also a half. So anytime you have parallel lines, they have to have the same slope or eventually they would crisscross. For perpendicular lines, just a reminder, perpendicular means they make a 90-degree angle where they intersect. I want to take a look at these slopes. So if I were to count this slope, maybe from here to here, I could count. So I'm going to go down 1, 2, 3, 4, and over 1. So my slope for the first line is -4/1 or -4. And then for this line, it looks like I could start here and count to here. So I'm going to go up 1 and over to the right 4. So 1 and 4. So my slope is 1/4. So they do have a relationship between their slopes. They're definitely not the same. In fact, they are flipped and they have opposite signs. So if one's negative, the other's positive. So that's kind of the rule we have to memorize, and hopefully we remember a little of this from algebra. So parallel lines will always have identical slopes. Perpendicular lines, however, have opposite signs. So one will always be negative, one will be positive, and they need to be reciprocated or flipped. So parallel slopes could be like 3x and 3/1x, right? Same thing. I could have 1x and x, same thing. Those mean parallel lines. Perpendicular slopes, however, could be like 1x and -1x. So 1 is flipped from 1, so they're opposite signs, they're perpendicular. You could have 5 and -1/5. You could also have something like 2/3 and -3/2. So very strict rules with perpendiculars. We don't want to mess this up. They must be different signs, and they must be flipped from each other. So it's either both parts or nothing. So we're just going to do a parallel line example. So you always need to solve for y, okay, in case it's not already done. And then it's really good for you to write down what your slope is and what point you're using for your new line. And then you set up your formula down here and you simplify. So it says write the equation of a line that's parallel. So right away, parallel means same slope. So we're going to have to solve for y first. So we're going to subtract 4x from both sides. And then we're going to divide everything by 2. So we get y equals -2x plus 3. So the only thing that matters in this equation is the slope. The rest of it we don't care about. This is going to be completely useless. We don't even need that. The -2 is what matters, so that's the slope that we'll be using since they're parallel. I'm going to copy that slope. And then my new line goes through this point right here. So we're going to use 6, -10 as our ordered pair. And now that I have these 3 pieces of info, I can plug them right into this point slope formula. So it'll be -10, -2 goes in the middle, and 6 goes in the end. And then we just solve for y. So the equation of the line that's parallel is -2x plus 2. So we'll do one more here. Write the equation of line parallel to this one. So y is already solved. That means you're good to go. You can just identify what your slope is going to be. So in this case, it's 1. And it goes to the point 5, 1. So we're going to set up y minus y1, which is 1, equals m, which is 1, times x minus x1, which is 5. And then we just solve. And if you go through the steps, you should get x minus 4. Okay, perpendicular lines are basically the same thing, only you have to remember that you're going to have to change the slope using your memorization rules. So first things first, we need to get y by itself. So we are going to add 7/4 x to both sides. Okay. So my current slope right now is 7/4. But if you want a perpendicular slope, you have to change the sign and you have to flip your fraction. And the point that you're supposed to be using for this new line is 14, -1. And that's it. That's the information now. It's just like everything else we've been doing. So I'm going to put -1 here, my fraction slope here, and my 14 here. And then we just go through and we distribute and solve. Okay, we should get -4/7 x plus 7. All right, the last part of our notes is going to focus on special lines like horizontal and vertical lines. These are easy because they don't require any work. You just have to memorize which way the line goes. So if you see an equation that says y equals 2, okay, it's kind of weird because it has no slope that we can see in that equation. It doesn't look normal, right? It doesn't have any x's. So right away I know it's special because it only has one letter. That means you need to graph a line so that all the y's are 2. So here's 2 on the y-axis. That means your line has to go like this. Otherwise, it won't always be 2. And then I want you to add a note here that horizontal lines will always have a slope of 0. And then vertical lines, same kind of concept, only this time it says x equals 4. There's no y in the problem. That means we don't care what the y values are, but all the x's have to stay 4 at all times. So this x equals 4, x equals 4, x equals 4 would be all these points right here. And as you can see, vertical lines will always have undefined slopes. So if we really quick go through and graph each line, it means all the y values stay as 2. So 2's for everything. All the x values stay as -3. So it's going to look like this. -3 for all my x's. All my y's are 0, so it goes left to right. So left to right, always at 0. X equals 0 means all my x's have to be 0. There we go. So again, very, very simple for those kinds of lines. All right, and then the last few examples, you have to determine if the lines are parallel, perpendicular, or it could be neither. So really quick for A, B, and C, what I want you to do is pause the video and go through and solve for Y and all the problems that need it, and then unpause and see if our answers match up. Okay, so you can check your answers, see how you did, and remember, all that we care about are slopes. That's how you make your decision. So if you look at the slopes of each line, okay, they're the same, so they are parallel. Over here, my slope for this line is +1. My slope for this line is -1. So in this case, our slopes are opposite reciprocal, so the lines are perpendicular. Just a reminder, upside down T's mean the word perpendicular. And then for this one, we have to be really careful. This slope is 1/3. This slope is +3. So while they're flipped, that is true, they are flipped of each other, they are both positive, and perpendicular lines have to strictly be different signs. So these are neither. And then no work is needed with letter D, because if you think about this, this is a horizontal line, so it goes like this. This is a vertical line, so it goes like this. Well, horizontals and verticals will always make 90 degrees. So no work needed. You can go ahead and say all horizontals and verticals are perpendicular.